Hi everyone, thank you for coming here to listen to me talk today. I'm Justin Sim. I'm an IIoT engineer from IMI. So we're partners with Cyclect, and today I'll be sharing more on our leak detection solutions. So I'd like to share a little bit more on Organ Cloud, which is a cloud platform that we've been developing. Also, what exactly is Organ Cloud? It's actually an IoT platform technology stack, complete with the API, user interface, encryption technologies, algorithms and data analytics, and data broker, compiled into one package for ease of usage. Organ Cloud itself was already prepared for cloud and on-premise versions. So this is actually more targeted for customers who are more security oriented. They prefer to have their data hosted locally in their sites. So we have the option for them to also do so. So Northern Cloud was already is compatible with many of our common technology stacks and common communication protocols such as MQTT, MQTTS, IO-Link, Modbus, RS-485, RS-232, so on and so forth. And it's data transmission encryption ready, and the role-based data ingestion and retrieval ready. And at the same time, it's versatile enough to communicate with many of our products existing, such as pressure sensors, flow sensors, valve islands, mass flow controller, so on and so forth. So, two of our success stories I'd like to share our products. One of them would be the Northern Cloud ready sensors and controls. The NCRS was designed in order for you to have a more plug-and-play experience. It's available in both wireless-based and PoE-based formatting. The wireless-based sensors will piggyback off the customer's Wi-Fi to connect to our cloud and then transmit the sensor data to a dashboard that customers can view. Same thing with the PoE-based. The customer's data will be ingested through the PoE switch. Sorry, this will be the wireless sensor. So you can see a sensor is able to be charged. It can hold a battery for use on site, after which it will be sent to the cloud where the customer can actually see it on their own phone, tablet, or maybe even a provided tablet if they wish us to set up. So for the PoE based one, PoE based, you will have the single cable, LAN cable, to provide both power and cable internet connection. The sensors will then go through the internet switch, the PoE switch, to send to the cloud, after which same thing customer will be able to view the data on their own device. So why bother with Organ Cloud Ready sensor? Why did we come up with all this? The conventional approach to adding a sensor to a cloud would involve many layers of engineering. As you can see here, let's say a typical factory owner wants to add a sensor to their technology stack. They will need to first get the sensor and the control, after which, let's say they use IO-Link, they have to add an IO-Link master, connect it to their PLC, hook up to their HMI or SCADA to the interface, connect to VPN and internet, add the historian database and the front-end UI. Each layer of all of these needs additional engineering hours. With the IMI approach, we are hoping to simplify all that with just a single cable or Wi-Fi connection, and then with a single subscription, they can connect easily. So, I'd like to share a video of how this is akin to a customer adding a new sensor to their Northern Cloud subscription. As you can see, it's almost immediately added and tied to their account. After which, let's say the customer wants to monitor like the pressure and flow in their process line. Immediately, they just need to set up the pressure sensor here, connect up with, let's say, an additional flow sensor to monitor as well, hook up to their process line, and connect a single PoE cable here in this case. So the sensors immediately powered on. You can immediately see the sensors already active and running. So customer can already ingest the data into a cloud platform. They're able to monitor, receive notification, and control when necessary. So 3 simple steps: log into the cloud platform, scan the QR code to tie the sensor to your account, connect to the internet via the available methods, and install that process line. So a success story for this is recently we've installed such a local setup actually in US Embassy in Thailand, where they actually needed to monitor the pressure lines for their broadcasting center. So when they actually use the cylinders to close the circuit and it's not closed fully, it causes major arcing, causes damage to their equipment. So with the sensors, they are able to detect quickly whether there's any leakage and thus detect whether the circuit is not being closed correctly. So we managed to solve the customer's problems by customizing the solution to their needs, and it's versatile and adaptable enough to fit various scenarios. So with normal cloud ready sensor, it's actually pretty easy to hook up and connect various monitors to monitor online. You're able to put set points in order to detect alarms, receive notifications as well. So the other solution I'd like to share is actually on Pascal P, which is a water leak prevention system. This we actually installed this at Pilot Pen. I'm sure most of you have used a stationery from Pilot before, stationery. So their facility in Singapore actually had a water leak problem about 3 times over 2 years, which actually caused them a lot of water damage when it persisted over the weekend. So with this, they came to us to look for a smart solution which allows on-time notification and prevention as well. So with this, we actually customize our Bushos valve along with our Open Cloud Ready sensors to connect them so that the valve can work in tandem with a flow sensor to detect whether there's any flow in the facility after hours, and based on the algorithm to detect whether there's any leakage. And from there on, you can prevent the leakage by locking off the water flow to the area. So a dashboard will look something like this for them, where they are able to monitor and control the valves remotely, see whether there's any leaks at the moment, any alarms pop up, and then they can also see a notification if it's shown there. So this is just a video to, this is a video to actually demonstrate what it might look like. So you can imagine like this is, let's say this is your facility, your office building, there's 3 different levels, and currently all of them, there's no water flowing at the moment. So you can imagine like normally in the office when water is not being used, it's okay. So there's no water flow. So the system is smart enough to tell whether, or at least rather you can calibrate it to say that maybe certain amount of water usage is acceptable. But let's say we are now going to simulate a leak at level 3 of this facility, for example. So let's open the water flow. You can see sensors already updating immediately. Flow is coming in. So at first, like normal water usage, toilet, whatever it is, they won't trigger immediately. So to allow the water to flow a little while longer. Now the system might suspect, okay, maybe there's a leak in the facility. So I will want to check on whether there's a potential leak. So after maybe, for this demo purpose, we can set about like a few 30 seconds or so. You can see immediately the system starts triggering and saying, okay, there might be a possible leak, we're going to start testing. It triggers the valves in sequence to see whether there's still any flow in the facility. And if we notice that the valve has stopped, then we can conclude that there is indeed a leak, and thus the system works to stop and alerts the key personnel to come and inspect. So that's two of the success stories I'd like to share for Northern Cloud and what we've managed to do with adding the cloud paradigm to our Northern IMI products. Yeah. So, okay. Yeah, thank you very much. Thank you, everyone.